So, welcome you to my presentation. Thank you very much for the short introduction to the LF-Edge, and it is a pleasure for me to be here at the OSS 2024 in Vienna, and honor that I have the possibility today to present you our developments. My topic today is resilient edge computing, enhancing the resilience and performance of AI-based services through Open Horizon. You heard it before, as an embedded system in a hybrid cloud infrastructure in agriculture. That is our use case, that is where I come from agriculture, and we will look on the mobile edge as a game changer. Yeah, my name is Eberz-Eder. I'm the head of innovation and digital agriculture at the Agriculture Public Service Center in Germany, in Rhineland-Palatinate. Yeah, you will see what that means, Hofbox AI, in the next few minutes. My outline for today's presentation is a short introduction, location of our use case. It's very important because of agriculture, the necessity of resilience in digital agriculture, the increasing resilience through resilient smart farming, what that means, resilient edge computing as a solution. Our solution is the concept of Hofboxes, and hybrid IA-based services in agriculture, and a short conclusion and outlook. Yeah, empty grocery shelves are not the reality in our country, are they? What happens when central internet and power-dependent processes no longer function? Our world and the processes stand really still. Yeah, after a talk in 2080, where I talked about the need for resilience of digital infrastructures and crisis, I received the answer that we won't have anything like that. No. You can see it in your daily life in the past years. It is our reality, times of crisis. Where I do even come from. Germany is located in Europe. It is the most populous country in the European Union. My home is Rhineland-Palatinate. You see it on the map of Germany. We want to build a digital infrastructure with applications that are accessible to all farmers. From a geographical perspective, Rhineland-Palatinate is very diverse. This then has an impact on also the agricultural production. You see the production areas in Rhineland-Palatinate. You see the topography of our country. Yeah, for you as an IT expert, maybe it's not common where the important data in digital agriculture come from. And you see there the geodata, there's important, the public data like information about soil, weather, current status, and forecasts are essential. You know that very well. Also the historical data, because of climate change, it's a very important part, and you can connect it with IoT data, sensor data in our IT framework. Improve farm measurements. That means precision farming, precise application of pesticides and nutrients. We can use satellite information. This gives a good overview about the NDVI, the vegetation index, with Sentinel-2 data, our free data for all. And on the lower one, improve local information. That means IoT sensor data improves the local information in different situations, soil temperature, moisture, and so on. Drones information, important through the growing season of a crop. It's a good use case to do it with drones. And the autonomous processes in agriculture, like the robotic, is going on. It's a constant development in our sector, digital agriculture. The robotic opened the possibility for autonomous processes in agriculture. And for the farmer, a very important part is the farm management. For many farmers, really the most important part in smart farming because of the high bureaucracy which they have. Yeah, maintaining resilience of food stocks and supply chains is a growing concern in agriculture. And what we are doing and what is our focus, digital systems, the use of regional sensor data in smart farming, you see it before, are very important for farmers, and the information improves knowledge base for decision making, IoT and local data use will increase in the next couple of years. And we have now the moment of crisis. Agriculture is a fundamental element of the critical infrastructure of every country. And therefore, in our opinion, decentralized data storage through the offline first principle has to be the first part what we have to focus on in IT architecture. And for us, open source technology is the key to success in this part. How it looks like, how it look our IT architecture to achieve the above goals now. First, do we have proprietary applications from the country that require a central data infrastructure? You see it on the right side, the S3 geodata management. It is on a public or private cloud, a central application, and very important for farmers to visualize geodata and geoinformation and so on and so on. Behind them are private clouds, and we have there some applications. You see it on the GeoBox viewer or agricultural meteorology. Farmers get the information from a central application, from a central server. Second, we have an important level of communication with the various networks like 5G or LoRaWAN for IoT networks. This can be organized in two ways, public or private networks. And that is what we have in the middle, the second part. We have also IoT, more IoT data, more localized data for climate informations because of the use of LoRa networks and IoT sensors. And the third step is the most impressive and the innovative one, the way to the edge. We call this third level resilient edge computing. What does it mean? We have a resilient framework according to the offline first principle. I will show you these developments later on. Please keep these architecture in mind. And you see the fourth part, the external Docker application. That means every proprietary software, containerized software application is possible to deploy on the edge. And that can be many open source software as proprietary. And it is in a hybrid cloud infrastructure, our hub layer. And now we focus on these left side of my slide of these resilient edge computing with Open Horizon. Eric, you talked about that, and I will show you what we are doing there. Resilient smart farming and resilient edge computing. Edge computing as a possibility to strengthen digital resilience in the field of agriculture, innovative IT architecture for our agriculture. Our innovation in it, infrastructure for our concept resilient smart farming is this kind of resilient edge computing. What does it mean? What does resilience in digital agriculture means? Why are we dealing with this topic? I show you for a few minutes slides about the current crisis in the world. That is one reason for our goal, so that agriculture sector is more resilient in the next future. Especially in actual secure infrastructures, the high effect of an event is high. That also says the vulnerability paradox. Yeah, but in agriculture science, we have to have a holistic approach to resilience in agriculture. What does it mean? First, the resilience of digital infrastructure, cybersecurity, emergency communications, what we are seeing in the next couple of minutes, and resilience from an economic point of view. As an agriculture scientist, I can talk a little bit about climate change, environmental problems, and structural change in agriculture and rural areas. That is all. In the future, it is very important to focus on these kind of resilience in agriculture. And when we talk about resilient edge computing, it is a compositum of resilience, adaptability and resilience, and the edge computing, a system architecture approach, basic data processing power at the point of origin of the data. And what we are doing is now to build these together as a Hove box concept and why it is important. I hope you noticed from I said earlier that agriculture is a good use case for edge computing. Here we have the need because of a critical infrastructure. Agriculture depends much on central infrastructure and cloud computing at the moment. Within edge computing focuses on the resilience and reliability of agricultural production. That means more the primary production. Edge computing could be a game changer for resiliency of digital infrastructure, also for agriculture. In our use case, we speak about resilient edge computing, and what I said, reduce risk and maximize resilience with our digital agriculture topic. And you see our architecture, and we will focus on this part. And we go to the graphic. This graphic shows how Open Horizon, IBM Edge Application Manager, and in our use case set up with two different layers. One is the hub layer, an administrative layer as client to manage thousands of edge devices. See in the Hofbox layer with agent component and works in one use case with the Geobox application or other application and the LoRa network on the third device layer. On the right side you can see the connection to different LoRa nodes. You see it on the Internet of Things stack. We are using different kind of solid data IoT sensors, and we have now three layers: a hub layer for the administrative infrastructure, a decentral edge computing layer, that is the Hofbox layer, and a third device layer, that means the IoT and network layer. We go through this slide, and you see now our prototypes of the last years. You see our first one is a Raspberry Pi 4 model with 4G GB RAM with embedded LoRa board. But in agricultural practice, LoRa network was insufficient on this Raspberry Pi. And we are going through the second prototype, the Hofbox 2.0 in the middle. It is Advantech device because we want to bring secure device onboarding in this process to automate the cycle of bringing Hofboxes to farms. And it is capable of the zero touch and Open Horizon agent, fully compatible and good results in our practice. And the next step was a Hofbox AI. It is an Intel NUC with CPU and GPU power. It is expandable for some kind of AI-based services, and it is possible to run AI functionalities on it. And it is, one of the most part, it is FIDO capable in the future. Eric talked about it before, and that's the reason why we need other hardware. It is on a Hofbox layer. And how our software services looks like, which are running on these Hofbox, on this hardware. All software based on containerization. Left screenshot shows the local dashboard and user interface in order to manage local software on the Hofbox. And the right screenshot shows on containerized application, called one of them as the Hofbox. And the Hofbox Geobox application looks like that. You have some kind of application with a farm profile, you have a messenger service, a map service, and we have an integration of Watson chatbot, central application in this hybrid cloud infrastructure in order to run chatbots. It's based, it is developed in 2021. You have to go before the hype of AI-based services, and table editor and an innovative data storage. And you see the LoRa sensor data on it. Yeah, what is the innovative local event store? Our innovative local event store called Booking Journal has a link to internationally accepted standard vocabularies and ontologies. That's very important for the near future to bring applications on the market which are running on internationally accepted standard vocabularies, especially in the domain of agriculture. We are using the ontology from W3C, and we are building a knowledge graph generation. This can be evaluated by any Sparkle queries, and explicit semantic data modeling for the realization of farm information system. And that's the base for our AI-based tools like the chatbots. From these application and this innovative local event store, we go to, you see these in our prototype as a Watson chatbot, and it's going, the Watson chatbot is going to the local event store and picking on the host box and going into the data storage and bring it as an example on the chat. One example of that is integration of Watson chatbot, and you see now the chat with a classical one, a chatbot with pictures as a decision tool for farmers to get more information. What is this kind of pest or diseases on the field, and you get the response automatically from the Watson chatbot and the information on a local innovative local event store. And our next step was to go more on the edge. Not to have a hybrid or a central AI-based service like Watson. We want to go completely local. And what we are doing with a new prototype of Hofbox AI with the Intel NUC, we can run AI-based models locally. We have not to go in the cloud. And it's very important by farmers in order to have more privacy. And we are deploying and running open source large language models on the Hofbox, and all with the Open Horizon framework. It's all deployed by Open Horizon, these containerized software, and the large language containerized software on the Hofbox. Why? It is offline first, but we have the possibility for hybrid functionalities. If you have internet connection, you have the possibility to go via a URL into the web space. But if there's no internet connection, you can run only local on your device. Strengthen data sovereignty of farmers. It's a very important part in farming. Creating own local-based assistant. Overwhelming opportunities, and what we are doing now is to have RAG as a solution in the near future to answer any question you have on your farm, on your own. That is what we are doing there with our LLM chatbot. It is flexible, scalable, and far-reaching advice for farmers. And it's running. it's not a fake. It's running on our Hofbox. And I talk about mobile edge comes to the farm. It's also on the Open Horizon hub layer. And what we are doing there is completely new on this overview, which was developed by the Open Horizon and IBM and Xperia. You can see on the right side now in the next slides the downloaded application on your edge device. You see it here. It is our Hofbox and the containerized software. I showed it before. And the next step was we are going now to the mobile device on the mobile edge, and the mobile edge comes to the farm on a smartphone. And you see smartphone, and through the Docker container software we have the possibility to get the same software on both edge devices, on the Hofbox and the first time on a smartphone, and we can synchronize it. What is unique in the world, however, is that we now have the ability to run AI-based services like Watson Assistant or open source LLM on the edge device. It means also if it's running, if the hardware is very good on the smartphone, they will run AI-based services also local, or that means like a Watson Assistant on the edge and in the cloud. In our picture, it is a Bug AI, a Watson chatbot with integrated image recognition. And you see it here. Due to the possibilities of edge computing and the containerization of software on a normal smartphone or Android phone, there will also be innovative solutions for agriculture in the near future. And in my point of view, it is maybe a game changer in the near future that we can deploy from a framework like Open Horizon, containerized software, not only on a small PC or small computer, also on smartphones like this one. And I come to the conclusion that crisis events have a significant impact on digital infrastructure, also in agriculture. Open source framework like the Open Horizon is suitable as a solution in our use case. Offline first principle as a standard for critical infrastructure. And the use of digital applications in agriculture can be a significant contribution to sustainable agriculture. We have to keep in mind that it's very important for our society to have a sustainable agricultural landscape, but it is better with digital applications. We know that. It is good. And in our opinion, open source is the key to success, because in our way the last years with the Linux Foundation and Open Horizon, we see that it's running and it's going forward, and we are happy that we can show you these results from our developments and minimize risks, maximize opportunities and benefits through resilient smart farming for sustainable agriculture. Thank you for your attention. Any questions? Where is? Oh yeah. Let's see.
Yes. We learned that the hard way last time. The offline first definitely makes sense, right? There's a question about where do you see yourself sort of storing the data that you need to keep for a long time? Is that going to be sort of on the farm? Meaning that you need to have some redundancy over there, as opposed to saying, no, that's a temporary thing, and as soon as I get connected, I will store the long-term copy somewhere else, right? Because some cases, like these edge monsters, architects, they say, no, just cache things locally, right? Just spool things. The real stuff lives in the cloud somewhere, right? The long-term things.
Yeah, that's a very good question, Eric. It is complicated because farmers want to have their data locally, but in order to have more redundancy, we have to go maybe on a second device or a second part of server. But we have, in my opinion, we have to look what kind of data we will go into another space. But it's very, very important to discuss this topic in the next couple of years.